Good morning everyone. Today we will talk about data analysis, page 159. Last time we talked about shadows, how to produce them, what are shadows, we define them, and which material can produce shadows. Now we will talk about analyzing data. We will take an experiment and analyze it, okay? Actually, this is a general topic, so pay attention because it will be repeated through the whole term. Some students used a toy animal to make a shadow, okay, on a wall. So we have light source, toy, and the screen is a wall. They put a bright light 1 meter from the wall. They put the toy at different distance. So this is our variable at different distance from the wall and measured the height of the shadow. So pay attention here and here. The variable that they are changing, it is the distance from the wall. The variable that they are measuring is the height of the shadow, okay? So what we will have here, the thing that we are change is the independent variable because we are changing it, so it is an independent variable, okay? The variable that we measure is the dependent variable because this result will depend on this variable. Changing the distance will change the height of the shadow. So the independent variable is the variable that we change. We are changing distance. The dependent is the variable that we measure. The independent variable will be put in x-axis and the measured one will be put in the y-axis. So let's take a look at the graph. Here is the independent one and here is the dependent one, okay? They took many distance. Our range, what is our range? Our range is the smallest value and the highest value. The smallest value is 10 centimeter, okay? And the highest one is 80 centimeter, okay? And here is the shadow height. Now, when you want to draw a line graph, okay, like the one that's drawn here, you have to put the independent variable in the x-axis, the dependent variable on the y-axis. You have to put units for both. This is called labeling. Labeling the axes is to put the name of the variable here and the unit. This is labeling. So first step, you have to do labeling. Put the variable name, put the variable unit. Then you have to divide these into equal distance, and this is called a scale. You have to provide a scale. So it is 10, 20, 13, 14, 15, and so on. And here it's 5, 10, 15, okay? And then you will put your result here with these small x's. Graph help us to see the pattern in the result. We can see what's the pattern? If it is related, no relation, increasing relation, decreasing relation, this is the pattern. This graph shows that there is a correlation between the height of the shadow and the distance of the object from the wall. The height of the shadow increases as the distance of the toy from its shadow increases. So you have ascending line. Now let's go here. So first we label the axis. Then we will interpret the data as a small x's. Now we have to draw best fit line. What is the best fit line? If you look at these small x's, you will not be able to join them in one line. You will not be able to draw one line to join them. So you have to draw the line with best fit. Drawing a line of best fit through the points makes the pattern clear. Best fit is the line that all the points are, let's say, distributed around this line evenly, or the line which can collect most of the points. So this is the best fit line. One point does not quite fit the pattern. Odd result. result. Odd results are called anomalies. Errors, they are errors. Perhaps somebody make a mistake when they made the measurement, so it is always a good idea to repeat your measurement. So you have to repeat this one and you have to repeat this one because they are not on the line, they are a little bit far away from the line. Let's go now to the key term. Okay, key term. Anomalous result. Result that does not follow the same pattern as the other measurement. It's the error. Okay. Correlation, relation, link between variable where one increases or decreases as the other increases. Either you have increasing relation or a decreasing relation. Line of best fit, a straight or curved line drawn through the middle of set of points to show the pattern of data points. It is the line that can distribute all your results around it, or the line that can have most of your result in it. Okay? That's it for today. Tomorrow we will continue with the pinhole camera. Thank you.